Hello, my name is Roy Gorgi. In this video demonstration, we have two projective planes, okay? Each consisting of 91 vertices, which is equivalent to the T-design C91 10-2 is equal to 91 blocks. We're going to determine whether these two projective planes are isomorphic or non-isomorphic using GIPSY's technology. The advantages of GIPSY's technology is that as the size of the two graphs get larger, the calculations to resolve their isomorphism only grows linearly compared to using automorphism or eigenvalues, etc. As a matter of fact, many of the calculations for GIPSY's technology are exactly the same regardless of the size of the two graphs, and there are only a few calculations that are a function of the size of the two graphs. We are using, for our video presentation, an Intel Core i7-6700 CPU running at 3.4 gigahertz with 16 gigabytes of memory. This graph design A, is one of four benchmark graphs called PP9-2, PP standing for Projective Plane, which can be found in the link in the description. The second graph, Design B, is another one of the four benchmark graphs from the same website. We will begin the search now. Here's the starting time, and as you can see after we press enter, the starting time is right here, and here is the elapsed time. It took approximately 35 100ths of a second, or 37 hundredths of a second, and as you can see, we determined the two graphs are isomorphic. In the case where the two graphs are non-isomorphic, the elapsed time is roughly 75 100ths of a second. There are still many improvements that could be made. This is a C# console application, and as a result, the elapsed time could vary between each run as opposed to if application was written in C++ or assembly language. But as it stands right now, the program is far more efficient than any other algorithm on the market. In the next video, we'll demonstrate whether two graphs with 273 vertices are isomorphic or non-isomorphic. There are many improvements that we are still attempting. We're always improving our technology, and there are a few other methodologies that we intend to implement. But as it stands right now, it is already very, very fast, as you can see from the elapsed times that we're getting. And we will be happy to answer any questions that you might have. As the graphs get larger, the numbers start to grow factorially. As I iterated before, 91 factorial is a number that is well beyond the number of observable atoms in the universe. 273 factorial is a much, much larger number than that. But with GIPSY's technology, the actual calculations for most of the algorithms are standard and always the same, regardless of the size of the two graphs, as will be evidenced by the elapsed time that we get for the following video.